And we are live. Hello, everybody. This is the next webinar in the series of the webinars about Kotlin for the server side. It's me again, Anton Archipo from JetBrains. And today I have an honor to host Ray Tsang from Google. Hi, Ray.
Hey there, thanks for having me here. It's been
Yeah, nice. So
yeah.
let me just remind what has been happening before. So we had Victor Gamma from Confluent in December about Kotlin with Kafka, and if you missed it, you can rewatch the video. It was pretty nice presentation, a lot of interesting things about Kotlin and Kafka. Then we also had James Ward from Google about Kotlin with different Google Cloud APIs, a lot of different examples with different frameworks. It was pretty engaging. And today we have Ray with the presentation about Spring Boot, Spring Cloud using with Google Cloud platform and obviously with Kotlin. So without further ado, I will let Ray start the presentation, and the floor is yours, Ray.
All right, thank you. And thanks
So,
for having me here. There we go. I think the screen is on. Wow. Happy New Year, everyone. It's amazing to see the lively chats in the live stream. So please feel free to ask questions at any time, and Anton will be very nice and be helping me to see those questions and relay those questions to me because I cannot see the chat right now anymore. So let's get started. Today we're going to talk about Spring Boot with Kotlin and using some of the Google Cloud services and ultimately deploying this into Google Cloud for serving the application as well. Quick intro for myself. I'm Ray. I'm a developer advocate for Google Cloud, and I am a Java champion, but I also love Kotlin. It's definitely one of my favorite languages right now, also because it runs on the JVM. And we have a project that I helped start for Spring and Spring Boot, which is called Spring Cloud GCP. And this is the library that we're going to be showing a little bit today that will help you to potentially utilize some of the cloud resources and services very easily when you're developing your own backend for your applications. If you have any questions, you can find me on Twitter, which is at Satanism. So that's pretty much all the slides I have. So I'm gonna try to switch over to the demo application itself. Now, this demo application is an Android app. It's all written in Kotlin. Now, unfortunately for me, I done Android development a long time ago, but it's been a while. So somebody else actually wrote this app. Somebody else from JetBrains actually. We actually did this demo together with Hadi at Google I/O a couple years ago, and this is the demo application that we were able to show. And the application is basically a photo app, a photo gallery app, so that you can upload photos to backend, and you can store the photos, and then you will have a gallery there. However, there's nothing there because nothing is running. But you know, it's got some of the basic functionalities. So you have a gallery view here if you have all the pictures, and you can upload photos. I have one photo here I can upload later, and I need to be able to upload it to the server, store it, and then maybe have some CRUD operations, and maybe something fun like you know, maybe we can try to use ML to see what's actually in the photo. And this app is just a front end. And to connect to the backend, it's using retrofit. And it has already created some annotations here with the interface so that it can make the code to the backend. Okay, so these are the services that we're going to try to implement today. Hopefully, all of it. Right. So first is the ability to upload a photo, and then the ability to retrieve the photo and also delete the photo as well. Okay, and the goal here is that within the next, oh, I don't know, 40 minutes, that we're going to implement this backend, test everything, make sure it works, and deploy it into a production environment in the Google Cloud serverless products, and serve it on online, and then make sure that it works with the application. Um, I don't know if this is going to be possible in 40 minutes, but I'm going to try. All right. So rather than looking at the backend right now, I'm going to go to, rather than looking at the front end right now, I'm going to go to the backend. Now, to develop this backend, I'm going to be using Spring Boot. Now, why Spring Boot? It is definitely one of my favorite framework to use because, well, first of all, it's pretty popular and widely adopted in the community, especially in the JVM community. And secondly, I have been a Spring user most of my professional career as a Java developer, so I'm pretty familiar with it. And finally, there's just a lot of support for Spring Boot across all of the ecosystems. So, maybe starting off, you can write a simple REST API, and then you can integrate with different databases and different messaging systems if you want to. And in our case, we're going to be integrating with our cloud services. Okay. So to do that, I'm going to go to start.spring.io, the Spring Initializer page, and this is where you can bootstrap a new Spring Boot application. Now I think that there are many Android developers watching this potentially as well. So if you like, you can use the Gradle build file if you want to. However, like I said, I'm mostly a Maven person, so I'm going to use Maven instead. But they're going to be pretty similar. Language, of course, we want to use Kotlin for this. And one of the things that you can do when you create this new project is to pick and choose the type of technology you want to utilize. So for example, we're going to create a web API, right, a RESTful API. So we're going to add Spring Web to it. Okay. The other thing that I may want to do is to expose some CRUD operations via a ORM framework with Spring Data. So I can expose these operations very, very easily without having to write any code by using the REST repository. Okay, so I'm going to show how this works in a second. And finally, because we're going to run this application in the cloud, but we're going to utilize some of the cloud services for storing our images and storing the data. For this reason, I'm going to add GCP support. Okay, so just remember when you are creating this new application, you can pick and choose the components you want to add, services you want to use. And for Google Cloud, we have GCP support here. And then I can just go ahead and generate. Okay, and I can open this up. Let's see here, and open up the application. All right, I'm gonna full screen this as well, and this will go ahead and download all the dependencies for you, and it will have the build file. In my case, it will be pom.xml. If you're using Gradle, it will be the Gradle build file. Okay, and now this is the application. Okay. And as you can see, with Spring Boot, it's a pretty simplified in terms of it really wants to use convention over configuration. So rather than configuring your app explicitly, you can just create your application adhering to certain conventions and adding certain annotations. It'll automatically apply all the right features for you. Okay. So in this case, this simple application will actually run, and it will start and listen on port 8080, and that's pretty much it. With Spring Boot, you can create a very simple, REST endpoint or just respond to HTTP by creating a controller. Okay. So for example, in my case, to start with, I'm going to say hello controller, for example, something very, very simple. And I'm going to have a method that will basically return hello when you hit the endpoint. So I'm going to say hello. Now that's a simple class, but then as soon as we annotate it with a REST controller, then this becomes a RESTful service. And then I can then map this function to a get method or a post method, delete, or whatever other HTTP methods that you want. In this case, I'm going to map it to get and just listen on the slash. Okay, and that is the most simplest, basic Spring Boot application that can respond to a request on the port on the index here. So let me go ahead and try to run this. Just make sure everything still compiles and everything runs before I move on to the more complicated implementations. Okay, and now you can see I actually went to IntelliJ on the top and just click on run. And at the bottom here, I can see that this application is now running, and it started fairly quickly in about 2.6 seconds. And now I can make a request. Now I can use curl, but I'm in IntelliJ, so I'm going to create a new test.http file. And here I can simply say get HTTP localhost 8080, and then I can run this request, and hopefully I will be able to see the result. There we go. So here's the result, and I can see hello. And that's really all it takes to do a very simple hello world. But today we're going to move beyond hello world. We're going to implement the backend, right? And we have a lot of things we need to implement. So the first thing that we may want to do is to have some kind of entity that we can use to store the information about a photo that we're going to upload, a picture. Okay. And for this, of course, I'm going to create a POJO in this case. In Kotlin, this will be a data class. Okay, so for example, I'm going to create a new data class called photo. And this photo may have an ID. So I'm going to say there's an ID here. Oh, set it to null. And maybe URI. This is where the photo can be downloaded from, for example. And then maybe some label if we have the time to do some stuff with machine learning, then we can potentially label these images. Okay. And the other reason why these are question mark here is because these values could be null. Mostly because sometimes during the JSON serialization, when it's converting from JSON to the object, it's not always guaranteed that some of these fields are going to be non-null. So during this serialization, it's pretty common that these end up to be nullable. Also in the database, sometimes the database schema may have these attributes to be nullable as well, and you have to reflect it here too. Okay. So that's a simple data class, but in order to store it into a database, you need some kind of ORM framework, object relational mapping framework, or you need to connect with the Java JDBC driver that the driver can then connect to the database. But that will be very raw. You need to maybe create your own SQL statements, or you can turn this object directly into an entity within the database by using a ORM, object relational mapping framework. And in Spring Boot, there is a framework called Spring Data. It's a component of Spring Boot. And if you're using Spring Data, then this can be easily turned into what we call the repository or a data access object that can provide you the CRUD operations on top of this entity. So it will do the mapping for you automatically behind the scenes. Spring Data supports many different databases in the backend. Okay, so for example, the typical ones are MySQL and PostgreSQL, for example. It also supports NoSQL database like MongoDB, etc. And also cloud databases like on Google Cloud specifically, you might be familiar with Firestore. If you are coming from Android side, Firestore can be something you can use, or Datastore, which is the non-real-time NoSQL database on Google Cloud, or if you want to have some more scalable relational database, then you can use something like Cloud Spanner. Now, Spring Data has support for all of these databases, and today we're going to use, for example, Datastore, just because it's a little bit simpler for me to use it. So how do I actually add a database to this application? I can go back to the build file, and I can simply add the Datastore component to my Spring Boot application. Okay, so in this case, I'm going to add a single dependency called Spring Cloud GCP starter data store. And what this will actually do is to bring in all the functionalities of Spring Data, so you get this nice ORM capability, but also the ability to interface and use Cloud Data Store, which is our NoSQL database that you can use to store a lot of different types of metadata. Okay, so just by bringing in this component, Spring Boot through convention will automatically configure the application for you. So now it can connect to the data store behind the scenes. Okay, but in order to map this entity into the data store fields, for example, first we may need to just add another annotation here to tell Spring Boot that this is a entity that we can persist into data store. And then for the ID field, we can just annotate it as an ID. That's it. When we save photo, store that into data store, all of these fields will be properly mapped in the backend in the database. And then we can go ahead and create an interface. So rather than implementing all the SQL statements or insert statements and stuff like that, Spring Boot and Spring Data can automatically implement all of those things for you if you just declare the interface. So in this case, I'm going to declare a photo repository, and this is going to implement the data store repository, something like that. And then it needs the type of the entity. So the type of the entity we want to store is photo, and the type of the ID, which in this case is string. And that's pretty much it. And then you can annotate this interface as well. Repository. Yep, there you go. Okay. So just like that, this application now has CRUD operation to save photo. Right? How do we know this actually works? Well, the only way to find out is to actually test it. So what I'm going to do then is to make a simple, right here, I'm going to make a simple post method here so that we can test this out, right? So for example, here I'm going to say, let me see here, create a new photo. And this is going to be photo. And this photo object is going to be coming in as a JSON format. So I'm going to also mark it as a response body. And in order for this to be triggered from HTTP, we have to add the mapping, just like previously we have the get mapping, and now we need to do the post mapping, right? So here we can do a post mapping, and I'm going to say post to photo, for example. And oh, sorry, this is the request body. Okay. And now when we post to the /photo URI with the JSON payload, then this will be populated, and now we can save this record. So for example, I can use the photo repository to save this record. Now, this photo repository can be automatically injected into your class. Right? This is using dependency injection. So rather than creating a new instance of the photo repository, what you need to do is to inject it. So in this case, we're going to use private val so that this is a private member, but also an immutable member. And we can say that please inject an instance of the photo repository into my class. And then when we are creating a new photo here with a new record, we can say photo repository.save, and we can just save this record, and that's pretty much it. Okay, and now we can go ahead and try this. We can stop and run. So we can restart this application with this new functionality. And then we can go back to test HTTP. And maybe we can do a post. So I'm going to say post to photo. And the payload here, maybe I can say ID is test. And a label is Ray, something like that. And I can run this post. And the response is empty. That's because our function here is not like this mapping is not responding anything, so there's no response whatsoever. But it is a 200 success. So what that means is that this operation actually succeeded, which is great. And now we can actually go back to our Google Cloud Console, for example. And this is the Google Cloud Console. In here, you can find many of the Google Cloud services. What we just used is data store. Okay, so here we can go to data store. And I can see entities right here. And then there are different kind that we created, right? So previously I had a kind called person and user, and I just created a new kind called photo, and I can click into that. And here we can see we have test and Ray. Now you might be saying, wait a second, that could be fake because it's been there this whole time. You're absolutely right, it might be. So just to prove to you that this still works, I'm going to say Anton here, maybe, and do another post. Oh. Okay, and come back here. And let's see. I wish they have like a refresh button somewhere, but there's not. But there it is. There we go. So now we have test, and now it's Anton instead. Okay. Now, what happened behind the scenes? There's a lot of things that just happened, right? First of all, somehow my application is able to authenticate with my Google Cloud project. And the way that this has been done is all fully automatic behind the scenes through the auto configuration that we provide you with our Spring Cloud GCP components. And what really happened behind the scenes is that when the application is starting, on the top here, you will see that a log entry here that it says your application has been authenticated using a credential. Okay, and this is a default credential. Now, where does this credential actually came from? You can see that I did not actually specify the credential in this application whatsoever. Well, when you're using these type of integrations with Spring Cloud GCP, the credential is automatically retrieved from your gcloud command line. Okay, so gcloud command line is the command line you can use to interact with Google Cloud. And the command line is already authenticated with Google Cloud. So as long as you are authenticated with gcloud, then it will be able to share this credential with the application running on that particular machine. Now, the nice thing about this is that because you're not specifying any API keys, you're not specifying any username and password, you don't have to worry about, well, first of all, leaking those credentials. But secondly, when you're deploying the same application into a Google Cloud environment, this application also can automatically retrieve and interpolate the credential that's associated with your runtime environment. So you never really need to embed any credentials into your application when you're running on Google Cloud. Okay. So just remember, the on your local machine, you're authenticated with gcloud, and your application can automatically pick it up. In the deployed runtime environment, your application can pick it up from those environments as well. So you don't have to re-embed any of the API keys or service keys or anything like that. All right, cool. But this is a lot of work to create CRUD operations over and over again for the entire app. So instead of doing this manually, Spring Data has this other feature which allows you to expose this entire repository as a REST service. Now remember, when we first created the application, we created it with the REST repository. So what we can then do is to change the notation to repository REST resource. Okay. And just by doing this and restarting the app, now automatically I will have CRUD operation exposed as a REST service for my repository rather than me having to implement everything manually myself. And that is definitely one of the really nice features of Spring Boot and its integration. And a really, really easy way to kind of get started and develop some proof of concepts and then later enhance it even more. All right. So how do I know this is working? Well, I'm going to use the get method here again. And rather than going to /photos, the repository is going to be under photos with the S. And if I do a get, now I can see this is all fully auto-generated for you. And this endpoint is now returning a JSON payload that gives me the content of my repository. Now, in addition to just giving you the whole list of entities, it also implemented pagination, right? So rather than implementing pagination yourself, this is another really, really quick and easy way to just get this pagination functionality. So if you have more than 20 elements, it will be on the second page, and then you can paginate across over through all the record sets that you have. Okay. And every entity also can be keyed by the ID. So like in this case, this URL is photo/test. Test was the ID that I used. And we can actually see this as well if I try that. And you can see I can address my application. I can address this particular record by the fully qualified URL. All right. And that is one of the first parts we needed for our Android app, right? We need a way to list all the records, all the photos, and this is definitely the first thing that we can do. All right. Then we may want to upload the image and then save it somewhere. Now, where would you save a picture or a video on the cloud? If you're running in a VM, like a virtual machine, then maybe a lot of times, the more traditional world, we would save the binary payload onto the disk, right? But then that is not shareable potentially between different machines, and you will have some scaling problems, right? Eventually, you run out of disk, or just one machine is not enough, and then you have to shard the data. You have to do a lot of work to just make that work. So rather than doing that yourself on Google Cloud, you can use something called Google Cloud Storage. So Google Cloud Storage is a place where you can store as much data as you want, basically any binary data, all the cat videos if you want, right? You can just dump everything in here, and you don't ever have to worry about running out of space. Okay. So for example, to store our pictures, we're going to put them in a bucket. In Google Cloud Storage, everything is organized into a bucket. So we can create a new bucket here. You can give it a name. I'm going to say dash photos. Okay. And this bucket name is globally unique. Okay. So no one else can use this bucket name anymore once I create it myself. And then the bucket has different configurations for different availability need. Your bucket can be regional or dual regional or multi-regional. Okay, this is really just about their failure mode and how much data is being replicated across, so that in case one region has an issues, the other region can pick up all the workload and continue to serve the data. There's a lot more configuration here. I'm not gonna get into, but I'm just gonna go ahead and create. Okay, so now I have a bucket, and this is where I can store all the pictures. So the Android application is going to call endpoint called upload, and it's going to post a multi-part file through that endpoint. If I go back to the retrofit configuration here, it will be this part. So it's going to upload a photo through multi-part body. Okay, and it's just a standard way of uploading binary data through HTTP. So what we're going to do then is to implement this real quickly. Check the time. Yeah, good. So we can just go ahead and create a new controller. In this case, I'm going to create a new class upload controller, something like that. And remember, this is a REST controller. And I am going to implement a function called upload. And this will then have a file called the multi-part file in this case. And I'm going to, once the photo has been uploaded, I'm going to save the record into our data store as well. And I'm going to return that JSON payload, that record via JSON payload too. Okay. And we need to annotate this function a little bit more to specify like its own behavior. So for example, this needs to be mapped to a post method /upload. And the file itself is going to be a request param. So this, rather than a request body, now this is a request parameter because of multi-part. And I'm going to call the parameter just file in this case. Now, how do I actually save this file? For this, what we can use is Google Cloud Storage, right? And you can, of course, use the Cloud Storage API. But within Spring Boot actually give you ability to store and interact with different storage backends through the concept of a resource. Okay, and we can also utilize this abstraction and utilize a starter for it. And whenever that you need to figure out, hey, how do I do something on Spring Boot with Google Cloud? One of the easiest way is to search for it, and I would highly recommend just being able to search for, say, Spring Cloud GCP. This will be the project that you can use to find all the integrations that you need. And you can go into this site and then go to learn. And then we have really, really good reference documentations. I'm going to click on the version I'm using right now. And as you can see here, on the left-hand side, you can see all the different types of integrations that we have. So for example, instead of using data store, maybe you want to use Firestore, then you can click into the documentation to see which dependency to add and how do you perform implement the object relational mapping. Okay. But now we're going to use cloud storage. So I'm going to go to the documentation and I'm going to find this particular dependency to add. Okay. And that's pretty much it. So I'm going to load this dependency in, and now my application will have the ability to interact with my Google Cloud Storage bucket. Okay. Now, how do I actually do that? Well, first I need to have a URL that will be uniquely addressing this particular bucket in the file. So let's just document that somewhere. So here we're going to declare a private val called bucket. And the bucket name is wise coyote 827 slash, I think, photos. Is that right? Photos, yep. Okay. And we need to prefix this bucket with gs colon slash slash. This is just the protocol or the telling Spring Boot that this is a Google Cloud Storage address. Okay. And then maybe I'll put it under images in a subdirectory instead. And then for the file, when we are retrieving the file, we don't want to use the user's file name, right? Maybe the file name is too long or the file name is not great. So instead, we're just going to randomly generate a file name for this particular file. So I'm going to use UUID and randomly generate a string from UUID. So this will become the file name. And then the full URI for this particular file, the pointer to this file, will be a combination of the name of the bucket and the ID. Now, as you can see, this is really nice by using the string interpolation here with Kotlin. So it makes some of these string compositions really, really nice and easy. Okay. And also, of course, we shouldn't be using vars everywhere. This should just be a val so that this becomes immutable too. Okay. And then we can use Spring to upload this file into the storage. So for this, what we can do is to get the resource reference by using this URI, and then we can upload it. Okay. Now, how do I actually get this reference? This is something that's really unique with the Spring Boot framework, which is that you can get the resource from the application context. Okay. So here we need to inject a application context called CTX. And from this application context, we should be able to create a resource reference. And from that reference, we can then upload the file, or we can retrieve the file. So for example, here we can have a reference to the file by using the reference and using get resource. Okay. And the URI for this resource is the one that we constructed. And because we want to write to this file, we want to write the input file into this resource, we're going to do a cast here as a writable resource. Otherwise, the resource is read-only. You can only read, you cannot write. But in this case, we want to write, and so this becomes a writable resource. So now, with the file uploaded, we can then use the input stream here. And in Kotlin, you can use in this case, which is really nice. So you can use this input stream, so you can also automatically close it when you're done with the block. So we can say this is the input. And then for the GCS resource, because it's a writable resource, now you have the output stream. And then you can use that as well, so that you can also close safely. And that will be the output. And then also thanks to Kotlin, it has some really nice utility extension methods. So in this case, for the input and output, I can say input dot copy to the output. And that's it. So what this will happen then is when you upload the file, multi-part file, we'll read it from the input stream, and then we'll write it to the output stream via this copy to. And then at the end of this block, everything will be closed, and the file will be saved. And that's really it. And then finally, we want to save this record once it's saved in storage. We want to save this record into the repository as well. So remember, we can just inject the photo repository, okay, via the constructor. And then we can say photo repository.save with a new photo. And the ID is the ID that we created. And the URI is, in this case, I am going to use, I think, slash image ID. The URI is what the Android application will use to retrieve the image later. Okay. And finally, we're just going to return it. Okay. And this is a really easy and simple way to be able to retrieve a file that's being uploaded and save it to Google Cloud Storage. Now, how do you actually retrieve the data from storage, though? This is just writing to it. So what we also need to implement is potentially a retrieve function. So we need, for example, to be able to get the image from the ID. Let me see here. Let me call it get, right? So I can call this ID string, and it's going to respond a response entity of resource, okay? Something like that. Import that. Yeah. Why resource? Because remember up here we can use the application context to get a resource with the URI. So now in order to retrieve the image, all we need to do is to reconstruct the URI and then create a resource, and now we can return it to the consumer. And that's pretty straightforward. And this will be a git mapping as well, and this will be image. Okay, and we're going to get the ID from the path. Okay, so remember here we're telling the Android app to retrieve the ID via this URI, and so we're going to have the git mapping that has the image slash and then the ID. And then for the ID, we need to just map it here too, so that we know this is coming from the path. Okay, and now we can use the resource to retrieve my image. So for example, I can say var resource is equal to context get resource. And this is going to be the combination of bucket slash the ID that we just passed in. And then we can say, return if resource dot exists. Then we return response entity dot OK, and the resource that we just retrieved. Else, we return the response entity of let's see here, HTTP status dot not found. Okay, and in this case, rather than doing the if and then return, what I'm doing return and then if, because in Kotlin, if is expression, so this is actually quite handy in this case. So if the resource is there, then we're going to return it. Otherwise, we're going to say not found. All right. Whew, that's a lot of work that's just been done, but we can actually test it if we want to. So what I'm going to do is to just go ahead and restart and run it. Okay, and let me see here. Got to restart my application, and still started relatively quickly. Now, whenever an application restarts this fast, I don't know whether it's going to work or not. So I'm going to see in the chat how many people think this will work versus not work. I'm gonna read this later, but I'm gonna find out myself too. Okay, so here I'm going to go to my test HTTP. Now there's actually a way to try this out, upload the image here directly from this HTTP file too, right? So for example, rather than just doing a simple get and post, I think I can do file. So this will actually allow you to upload a multi-part file exactly in the way that we are expecting for our service. So I'm going to upload the file to my upload URI, and this is pre-populated with multi-part form data content type. And then remember the field name, I changed the name to file, so this has to match up. And the file name can be anything, can be photo.jpg, doesn't really matter. And then I need to find a picture to upload. So the picture I'm going to upload is going to be, let me see here, I think I have one in my pictures directory. I have a cat picture. So I'm going to copy here. And just to show you what the cat picture looks like, there you go. Yeah, I think I took this photo somewhere when I was traveling, and it's really cute. Cool. So now I can just go ahead and try to test this out. So I'm going to say, let me go ahead and upload the cat picture via the URI. And the moment of truth, I'm going to post it. Okay, and this actually worked because I actually got a really nice valid response back. So what happened behind the scenes is that it stored the cat picture, in this case, into Google Cloud Storage. And then it also created a record in the data store. And we can go ahead and take a quick look of this as well. If I can find my Google Cloud Storage bucket, do a refresh. You can now see we have an image subdirectory. This is exactly where I ask the app to put my pictures. And then in here, I can see the uploaded photo and with the UID as the file name. Similarly, I can go to data store, go to entities, and now I can see the entry here with the newly created entity with the ID and the pointer to the image. Okay. I'm going to go ahead and delete the other two entries here. Now, ideally, this also means that the Android app right now can actually work with some minimum viable product right now. So I'm going to go to my emulator here. My app is here. So let's go ahead and give it a try. I'm going to. Oh wait, I can't because this app right now is actually talking to something that's running on the cloud, right? So this is actually not configured to talk to my local host. So what we will need to do is to actually deploy this application to the cloud. But before I do that, I'm just going to add one more functionality that could be fun, which is that I want to see what's in the photo, right? I want to be able to extrapolate what's actually in the picture. And to do this, we can use the Vision API, for example. Okay. And if you're not familiar with the Vision API, it's really just a service where you can send the photo to it, and it will tell you what's in the picture. Okay. And I'm going to use this really awesome demo Vision Explorer to show you what that looks like. So given a photo, for example, this one, which is going to be a cat, the Vision API can examine the photo and tell you what it thinks is in the photo. And this is called image label detection. Okay, so in this case, the image API, the Vision API can tell you that this is a cat, and it's also a British short hair with certain confidence in this case with a different score. Okay, but it can do a little bit more than just label detection, right? It can actually tell you extrapolate text. It can extrapolate the text in this case, right? This is a road sign with a kangaroo in it. But if you scroll down here in this demo, it can also extrapolate the text that's within the picture. So this can also perform OCR. And it can do much more, like it can do facial expression detections. It can tell whether you're happy or sad, or it can, in this case, tell you where this photo is taken from. And this is actually taken from the city field, for example. So it can do some identification of the photo or the picture. Okay. So what we're going to do is to just add one more capability to this app before we deploy it, which is by adding the Vision API capability. Again, the simplest way to figure out whether this is something you can do in Spring Boot easily is go to the documentation. And we happen to have a Cloud Vision integration here as well. And all we need to do is to add the dependency. And if I scroll down a little bit more, it will tell you exactly how to perform image analysis through the integration. Okay, so let's go ahead and add this. So what I'm going to do is here in the upload, once I have the image uploaded, I'm going to use the Vision API to see what's inside. And to do this, first, I need to add the dependency, just like that. I'm going to reload the project. Okay. And then it's what this is going to give me is a template, API template that allows me to code the Vision API. And so to use that template, I will have to inject that into my controller via the constructor. So I can say this is the Vision template, and that is an instance of Cloud Vision template, something like that. Okay. Now the Vision template is going to take in the analyze function, it's going to take a resource. It happens to be everything that we're using so far. So you can give it the Google Cloud Storage resource, or you can give it the file resource if you want to. So for us, we're going to analyze the image from the file, and this file actually has a resource, so we can pass in the right type. And then for the image detection, we're going to use the label detection here. And the response of this will be JSON payload, basically, that will tell you what's in the picture. Okay, so I'm going to just log it. So I'm going to say val response is equal to that. And just for troubleshooting right now, I'm going to say print it out for now. Okay, but it's going to have many labels inside. So rather than printing out everything, storing that into my repository, I'm just going to say response dot. Let's see here. with the labels, I'm going to maybe take 5 of them. So as maximum 5 labels, and maybe even sort it first, right? So I can say sort by descending based on the score, okay? If I want to, right? But in this case, all I want to do is to take, for example. So let's do take 5, and then map, because it's a entity. So I'm going to just grab the description, right? And then I'm going to join everything together, join to string with comma separator, okay? And this will become the labels. And finally, in my record, I can just say label is equal to labels, something like that. And let me just run one more test before I upload this and run this in the cloud. Okay. Again, if you have any questions, feel free to ask at any given time. Right. Ooh, exciting. I'm hoping this will actually work. Okay. So I'm going to upload this file again. Run. Post. Oh, you're right. So for the Cloud Vision API, it's a little bit difficult to test this locally, unfortunately, because of some permission issue. But I think since the app compiles, it's Java, it's Kotlin, I think it's just run. So how do we actually run this application? There are a couple of ways to run this in the cloud. If you check the server-side series, especially with James's session, he showed you how to deploy this application into Cloud Run. What I'm going to do is to try this in Cloud Run as well. But I'm going to do it slightly differently. Rather than building a container image locally here myself and do all the container stuff, which I don't really want to do right now, what I'm going to use is Cloud Run with its own new CI/CD integration. Okay, so what I can do is, for example, go ahead and create a GitHub repository for this. So let's take a look. I'm going to add everything. Okay, and commit the code, initial commit. And I'm going to publish this to GitHub. Okay, so here we have GitHub. I'm going to publish repository. I'm going to publish it to a repository called Photo Backend. I'm doing this live. I don't know if it's going to work, but we're going to see real fast. Okay. Now, one thing about running this on the server side is that, especially with Cloud Run, one thing you do need to configure is the port that's going to listen on. Now, for most of the Kotlin and Spring Boot applications, it's going to be listening on port 8080. But in Cloud Run, the port will be given to you in an environmental variable. So in Spring, you have to configure this environmental variable yourself. So we have to configure the server.port and map it to the envar code port. Okay, and then I can give it a default value still, so that in case the environmental variable is not specified, it will still use port 8080. But when I'm running this application in Cloud Run, then the environmental variable will be specified, then the server port will be different. Okay, so let me go ahead and commit this change as well. Commit, specify port. And then I'm going to go ahead and push this change too. All right. Now on the Google Cloud side, I can go ahead and deploy this application. Now, rather than again using container images directly, because that's what Cloud Run needs, Cloud Run actually just have added a really nice new feature, which is the GitHub integration from source code. So I can deploy this into Cloud Run as a running application simply from the source. And to do that, I can go to the Cloud Run console. I can create a new service. Okay. And I can give it a name. I'm going to call this a photo backend. And next. All right. And rather than specifying a container image, I can just click on this one, which is continuously deploy from a source repository. And I can set it up just by clicking on this button. What this will do is to connect with your GitHub repository. And it's loading all of my repository. I have many repositories. But once it's loaded, I can specify which one to connect to. And then it will actually set up a CI/CD pipeline for you automatically using Cloud Build. And Cloud Build is a CI/CD service on Google Cloud. So we can automatically configure this pipeline for you. Okay. So let me go ahead and find the repository I just created, which is Photo Backend. Okay. And click on Next. So it's doing the connection right now. And then GitHub uses main by default now. So I'm going to build from the main branch. And then down here, which is how you're going to build your app. So if you are using containers, if you're familiar with containers, if you have a Docker file, you can use that. But what I'm going to use is the build pack. So behind the scenes, Cloud Run CI/CD integration uses the Google Cloud Build Pack to build your application. And it supports Go, Node.js, Python, Java, and .NET Core. So my app is a Java application, so it will automatically detect it and then build the container for me by using the build pack. If you want to learn more about build packs, you can check out the session from James as well. I think he talked about build packs quite a bit in that session too. Okay, but just remember, they will automatically detect your application, perform the build, and then create a container for you. I'm going to save that. And then I can specify how much resources I want to give to this particular application. Okay, so for a Java application, for a Kotlin application running the JVM, we might need a little bit more memory. We might need, it'd be nice to use a little bit more CPU. For the demo, because I want it to be super, super fast right now, because we don't have a lot of time, I'm going to give it as much as I can. So I'm going to give it 4 gigabytes of memory and 4 CPUs. Okay, you don't have to give it that much for your app, but just for the demo, I want it to be faster. And then I can specify the minimum instances, because sometimes in the serverless world, when you deploy an application, maybe you have 0 instances to start with. And then all of a sudden your users are hitting your app, right? You're testing, running and hitting your app. And now you have to wait for the application to start. To avoid that cold start time, one of the best practices is to just specify some minimum instances that can handle those requests. And as you get more and more requests, we will automatically scale out your applications for you behind the scenes. But those very first few couple of requests, we can respond with the minimum instance here. So let me just run 2 minimum instances right now. And that's it. That's all I have to configure to deploy my app. And then finally, I want to make sure that this application is accessible from the public internet. And just for the demo, I'm not going to use any authentication right now. I'm going to create. What's going to happen behind the scenes is it's going to create a CI/CD pipeline for you. It's going to listen on the main branch. And whenever I check in code, it's going to build my application and then build the container image. And then finally deploy this as a Cloud Run service. And this will be the URL that I can hit to connect to my backend. And that's really it. Okay. Another way of deploying your application in a serverless world in Google Cloud is using App Engine. App Engine is probably the first pass that's been around for a decade. And with App Engine, you can deploy your Java application by simply deploying just a jar file. Okay, so whether you're using Spring Boot or Ktor or any of the other Java frameworks, most likely what you're going to end up with is a jar file. So for example, if I build this package right now and skip all the tests for now, out comes the jar file that you can just execute, right? And this jar file is located in the target directory. So let's take a look at that. So here's the jar file. Okay. And locally, you can just say java-jar, and the application should just work. Oh, java-jar with the target, like that, right? And your application will just work. In Cloud Run, you have to turn this jar into a container image. In App Engine, you can just do gcloud app deploy and the name of the jar file. So I can say this is the photo backend jar. You hit enter, and this will just do the deployment for you. Same thing in the serverless environment, scale down to 0 or scale up to however that you need. However, this will use the default configuration. As you saw in Cloud Run, the default configuration is a little small. So we can, in App Engine, we can also change out the configuration, but the configuration has to be changed out in the file. Okay, and this I'm going to cheat a little bit and find a file that I may be able to use or not. But here we can say this is Java 11 runtime, and we have the instance class, which is at 4, and then we're going to use manual scaling, and the instances is 2 or something like that. When I'm deploying my app, I should be able to say app YAML is equal to the app YAML I just created. Okay. So just showing you 2 different ways of deploying the same application into two different serverless runtime environments. So this is App Engine. Just do a gcloud app deploy. Let me specify the version as well. So I'm going to say version is equal to 1, for example. Okay, and deploy. On the Cloud Run side, let's take a look to see how this is going. Because it is doing the CI/CD build, so it's taking a little time for that to take place, but we will eventually see. Hopefully, by the end of this talk, we get to see at least one of these backends working, right? So I'm holding my breath here and see which one finishes first. Okay, so here we can see that revision deployment has finished, and we're waiting for the health check to begin. So that's a good sign for me. If I want to see the build status, I can go to Cloud Build, for example, and see the history. And there we go. Here we have a trigger, right? This is the photo backend that I just created. I can go into here to see the build, and oh, it looks like everything is green. And I should be able to go back to Cloud Run and see the service up and running. Crossing my fingers. And this is the URI I can hit. And I can see hello. Ooh, that's not bad. And I should be able to see photos. Yes, so this also works as well. And what that also means is I can make sure that this is the endpoint for my Android app to use. So I'm going to go a full circle now back to the Android app if I can find it. Where is my Android app? I think it's here. Okay, so here's my Android app and my retrofit configuration. Somewhere down there, I have HTTPS, and I can switch this over to my Cloud Run application. Okay, I'm going to rerun this Android app so that I'm connected to the right backend, and hopefully everything will just work. And that would be really nice if I can get that far. All right, here we go. Come on. There you go. Just run. Terminate. Is that how you do that, Anton? I hope that is. Okay. Oh, I'm so excited. I'm hoping this works, but for some reason, it's just taking some time to start this app for me in my Android emulator for some reason. That's too bad. I wonder what I can do to fix this. Let me stop the app completely, and maybe try this again. It says successful. It doesn't seem successful for some reason.
Perhaps it takes a while to load the app in the emulator when you have the presentation mode on and you are streaming, to the internet. Maybe your machine resources are a little bit too consumed.
Yeah. Well, that's I'm gonna do the big bang here and just stop everything, and hopefully I can just restart. Now, what? Oh yeah, okay, I got it. Yeah. Okay, so I think it was actually working. One second. I think just the UI that was weird. I think I got it. 1 second. Yeah, here we go. So let's double check here. There we go. Woo, not bad. Okay, so after some struggle with restarting my Android app, you can see now the app now is connected to the new backend, right? And it actually retrieved the cat picture that I uploaded through my IDE earlier. Which is not bad. And I should be able to click on this upload button and pick and choose this puppy here. I'm going to select and upload. Now it's uploading the picture to /upload. And now I can see the picture being uploaded. If I click into it, I will be able to retrieve this picture via the /image URI. And then I can see the label. Now the label is brown. That's kind of weird. So let's go ahead and see what actually is there. This is actually a UI issue. The UI is only showing you the first label. But now if I go back to my Google Cloud Console, right, and I'll just show you two things. First is the data store entry. Okay, and here you can see the puppy I just uploaded. And through the Vision API, it extracted the 5 labels for me, the 5 most relevant labels. And so brown, carnivore, skiing, dog, and mammal. So it was a dog. So it was able to get that far, right? That's pretty nice. If I were to see the logs, you're going to see exactly what the image label detection saw. So what I can do is to go to Cloud Run. Okay, I can go to this particular service I just deployed, and I can go ahead and see the logs. Okay, and you can see in the logging console here, remember I system print out the JSON payload. So this is exactly what I detected, which is interesting. Somebody uploaded purple, magenta, stuff like that. Yeah, colorfulness and animation and stuff like that, right? So that's pretty cool. So maybe somebody uploaded something. I don't know. It's live, so be nice. All right.
Indeed.
Yeah. And then finally, if I go to my storage, Google Cloud Storage, and see the browser, I should be able to see the pictures I just created. And here's the photo bucket. And here's the images. And there are quite a few images being uploaded there. So quite interesting. I know I just uploaded one, but I don't know who else uploaded something. I should have put a key on here, right? And this is very important for your Android app. The next step to this, of course, is to add authentication, protect your resources, and protect who can actually access which resource, and so on and so forth. Cool.
Nice.
So
Nice.
that's pretty much all I have. Yeah.
We have a full backend in under an hour,
I think so.
working and shining. So it was a very passionate discussion in the chat while you were presenting. You couldn't see those questions coming in, but there is a lot. I mean,
Okay.
it's not really like a lot of questions, but it's a lot of comments like, "Hey, we like it," and people are chatting between themselves. It's really great.
Yeah.
But one of the most interesting, I think, important questions that we have in the chat is that when you're developing something locally against the cloud APIs and you
Yep.
want to test it locally, then is it possible somehow when you code against Google Cloud APIs?
Yes, yeah. So for some of our APIs, we have emulators. So in fact, because we're using data store, this actually becomes pretty straightforward and easy. So let me go ahead and close this because we have everything running in Cloud Run. One of the things you can do is to use a different property file here, right? So when you're running a test, you may have a different property that actually for example, for data store, you can actually enable the emulator and set it to true. And so when you're running the test, then this will actually connect to the emulator instance rather than the cloud instance. And that's a really easy way for you to test your application locally. In fact, I do this so much myself with a couple of projects that I have worked on. The other thing that's really, really nice is that data store is a special case because it was really easy to just enable it. For everything else, you may want to use what we call test containers. And this is a open source project. This is not from Google, right? This is an open source project from the community. And one developer, Edu, a great friend of the community, he helped kickstart and develop the G-Cloud module. Okay, so with this, you can run emulators against Data Store, Firestore, Spanner, and PubSub. And all of these APIs are really, really great for you to test a database locally, to emulate your application locally. Okay, and there is a full documentation on how to use this. In terms of Spring Boot, you can then follow the documentation that will lead you to my repository, and this is how you can write integration test, for example, with data store using Spring Boot. Okay, and it will test against the emulators with a repository as well. So those are the two ways for you to write against the cloud, but also test locally. Finally, there are some stuff you just cannot test locally, like the Vision API. So for that, you may actually have to write like a wrapper that doesn't actually make the call and just respond something that's static, or you have to mock this yourself. Yeah.
So in theory, it is possible to run the tests without really making a connection to Google Cloud, right?
Correct. Yeah. Yeah.
Perfect.
Yeah. And that's something that you should strive for as well.
Yeah, and
Cool.
test containers is a really good project as well, like for all kind of integration testing. I agree. The other question that I think is worth answering is about the sources. So people are always passionate to try what you just showed them, and
Yeah.
we're asking if it's possible to find the sources somewhere in the
Mhm.
GitHub, both for the backend and the front end application.
Yes, absolutely. So we actually have the front-end application and the different backend on GitHub as well. And let me just pull this over. It's nice to have dual screen. So this is on the Kotlin repository, and this was for the IO 2019 server-side demo. And in here we have the Android application, which is the one we just showed you, and also the Spring Boot application that was written slightly differently, but has the same features. And also Hadi actually created a Ktor version of this. And also we support function, which is really, really interesting. So you can write a small function in Kotlin, compile down to the JVM, and we can run that piece of function for you. So it will be more granular than a full Spring Boot application, but it can be really handy to do some simple task you can encapsulate into a single function.
Perfect. Yeah, folks are asking for the same session with Ktor, and well,
Yeah.
here it is. We have a source code for you, and you can give it a try. But in our next series, we are already planning for a few next sessions about Kotlin for the server side with different frameworks, and we definitely are going to host a few sessions about Ktor. Uh, well, for the different use cases. Probably repeat something with Victor Gamma from Confluent. Maybe we do something for Google Cloud as well. But you can expect some more Ktor content coming up in the next few months.
Yeah.
All right.
Perfect. Yeah. And also the code I just wrote and deployed, you can find it on my site, on my GitHub repository on the photo backend. This is all written live in 19 minutes ago, so you can give this a try too. Cool.
Nice. All right. I think we can wrap it up here. And thank you, Ray, for showing it. It was an awesome session. Everybody liked it. And well, see you later.
Alrighty. Yeah. Thanks for having me. Thanks everyone. And if you have any questions, feel free to find me on Twitter @Sadism. Take care.